Okay, guys, this is a review of naming polygons. Make sure you write these down if you don't remember them. You'll have to know up to 12. And after 12, you'll see, even 11 sometimes I see it, but if you have a 13-sided polygon, you will see 13 gon or a 14 gon and so on. Okay, so if you ever see a 15 gon, just know they're talking about a polygon with 15 sides. All right, a regular polygon is a polygon that is equilateral and equiangular. If it is equilateral, you know that all sides are congruent. And if it is equiangular, you know that all angles are congruent. If it is a convex polygon, the diagonals are in the interior only. I'll show you better examples, but for instance, the diagonals here are in the interior of the figure. If it is a concave polygon, you can have a diagonal in the exterior. So from this point to this point, it is in the exterior, so it makes it concave. All right, so on this slide, I have examples of convex polygons, and concave polygons. All right, so you know how I said on the last slide that if it is convex, the diagonals are in the interior only. So, meaning from the points, from non-consecutive points, the diagonals are on the inside of the figure. Excuse my non-straight lines. You guys know how it is. But these points, these diagonals are only in the interior of the figure. Okay? That's what that means. Same thing here. Convex polygons, the diagonals are all in the interior. So, that was not a straight line. Okay, so we go over to the concave polygons. From these two non-consecutive points, if I connected them, they are on the exterior of the figure, you see? Same thing here. Any two non-consecutive points, they are not on the interior of the figure. It is concave. A good way that I've always taught my students to remember the difference between convex and concave. If you get to concave, I always think of a figure being caved in, like the star is caved, if that makes any sense. I hope it does, guys. So these are all concave figure, this figure and this figure. These are convex. All right, so you have a polygon angle sum theorem. Make sure you're writing down this formula. I think you've seen this before, but just in case you have not, I'm going to introduce it as if you've never seen it before. The sum of the interior angle measures of a convex polygon with n sides, and n stands for the number of sides, n minus 2 times 180. So I will ask you a question. Find the sum of the interior angle measures of a convex 15 gon. It's a 15 gon, so it has 15 sides. If it has 15 sides, then n equals 15. So you just plug it into this formula. N minus 2 times 180 degrees. N is 15. 15 minus 2 times 180. 13 times 180. And 13 times 180 is 2,340. So the sum of interior angles of a 15-sided convex polygon is 2,340 degrees. So all 15 angles of that figure would be 2,340 degrees. All right. Find the sum of each interior angle of a regular dodecagon. Okay, so first of all, they're asking for each interior angle of a regular dodecagon. Okay, regular means that all of the angles are congruent, and then a dodecagon has 12 sides. So n is going to equal 12. We know they are the same, so you're going to plug it into the formula. N is 12 minus 2 times 180. 10 times 180. 10 times 180 is 1800. So all of the angles will add to equal 1,800 degrees. But I'm asking for each. So I need to divide by the number of sides. So if there are 12 sides, I divide by 12. 1800 divided by 12 is 150. So each angle measure would be 150 degrees. So there's a difference in the questions. Here, they are asking for the sum of the interior angles of the 15-sided figure. Here, they want to know the measure of each angle of the figure. So just pay attention to what they are asking. Make sure you are writing these examples. All right, here they're going to ask you to find the value of x. You will use this formula and count the number of sides. 1, 2, 3, 4, 5. So n will equal 5. So I know that all 5 of these angles will have to add up to equal 5 minus 2 times 180. 5 minus 2 is 3. 3 times 180 is 540. So all 5 of these angles will add to equal 540. So that means this angle, 5x plus 3x plus 8x plus 4x plus 4x equals 540. So now I just solve for x. Combine like terms. 5x plus 3x plus 8x plus 8x is 24x. To solve for x, I divide both sides by 24. X equals 22.5. And that's it. All right, next we're going to talk about the polygon exterior angle theorem. Of course, exterior means the outside, and the sum of the exterior angles of any polygon is going to equal 360 degrees, okay? So if I want you to find the measure of each exterior angle of a regular decagon, regular means all sides and angles are congruent. All angles are congruent, all sides are congruent. And a decagon has 10 sides. So if it has 10 sides, you just divide. 360 divided by 10. So that means each exterior angle is 36 degrees. Each exterior angle is 36 degrees. It is that simple. Make sure you are writing these examples. All right, so here I want you to find the value of x. Again, I told you that the exterior angles of a polygon add up to equal 360. The sum of exterior angles is 360. So that means this angle, which is 4x degrees, plus this angle, which is 7x degrees, plus 8x degrees, plus 5x degrees adds to equal 360. Okay, this is a difference. These are the exterior angles. We're talking about these angles on the outside of the figure, not the interior, but the exterior. All right, so I combine like terms. 4x plus 7x plus 8x plus 5x equals 24. That is not a 2. Equals 24x. So 24x equals 360. When I divide both sides by 24 to solve for x, x equals 15. Be sure to ask any questions, guys. If you have any, I hope you are writing these examples. You will use this for your assignment.